Hello again. So, in this lecture, we're going to talk about like terms and distributive law. First things first, like terms, and here's a loose definition. We'll get a more concrete one as we go further through the lecture series. Like terms have the same variable to the same power. What I want you to concentrate on right now is the same variable aspect. So, like terms, for example, we could have one apple, let's call it 1A, and another like term to that would be 3 apples, or 3A. We could also have another example, let's be a little bit different. We could have, negative 5x, where x could represent anything. It could be dollars, so I owe somebody $5. Or I could even have, 100x. They don't have to both be the same signs. The most important aspect here is the variables. A and A are the same, so these guys are like terms. X and X are the same, so they're like terms. The same power part means the exponent of the variables are the same. So now let's concentrate on that. If I have, A squared, then another like term of that would be 3A squared. Or we could have, 100A squared. Or negative 5 billion A squared. But the main important part here is we have A squared, A squared, A squared. So they not only have the same variable, but the power is to the second each time. So that is what we call a like term. Same variable to the same power. Now what we're going to want to do is combine like terms. And maybe we'll say combine like terms, or we might use the vague word simplify. And it's kind of up to you to figure it out from there. So our first problem, we'll have 3A plus 6B minus 4A plus 17B. Now, they have to have the same variable in order to be like terms. And in order to combine like terms, we have to combine the number in front of them. So let's say we have $3. I'm just going to call it $3, okay? So A is the variable. B is not the same as A, so they're not like terms. But negative 4A here is the same, because it has the A. Notice I said negative 4. I know you're saying, well, it says minus 4. You can think, and this is bad on mathematicians' part, you can think of minus 4 or plus negative 4. It's the same statement. So I'm going to write these guys next door to each other. I have 3A minus 4A. And I still have all that other goop, plus 6B plus 17B. Alright, so let's concentrate on these guys. Because this is addition, I can do it in any order, that's why I manipulate it so. 3A minus 4A. It's like you said you have $3 and you spend 4. So you're just combining this coefficient part once you've determined their like terms. And 3 minus 4 is negative 1. And of course the like term comes along for the ride, A. Same story for the other guys. We have 6B plus 17B. Well, 6 plus 7 is going to give us 23. And B's coming along for the ride. Thankfully, the signs were both positive, so we didn't have to worry about anything. And A and B cannot be combined, so there's our final answer. Now, we're going to slowly have issues with variables. And you're probably thinking, I already have issues, but this is just the tip of the iceberg. We're going to have a thing called distributive law. And distributive law is the mathematician's way of kind of backing out of order of operations to make life a little bit easier. So distributive law states we have A times B plus C is equivalent to, or equal to, A times B plus A times C. And that's all we need to know. So what we do is we take that A and we distribute it to each term, to each letter inside the parentheses. And I can't combine B plus C because they're not the same. So how we're going to use this is if we're asked to simplify, and we have the dreaded case where we have 3 times and I should write my times sign, x plus 2. Now, they said simplify, so that tells us, oh, I should do something to this. And inside parentheses, we have x plus 2. X and 2 are not like terms. They can't combine. So in order to manipulate this, we look to outside the parentheses, and there's that 3 times that x plus 2. We take that 3, and we distribute it to each term. So now we'll have 3 times x, which I can't do much with, it's just 3 times x, plus 3 times 2, I can actually do something with, is 6. And that's a more, I guess, simplified way to look at it. And that's all.